Assume that A and B are x-intercepts and C is a vertex of a quadratic function. Y is equal to negative x squared plus 6x plus 7. Find the area of the triangle A, B, and C. Quadratic function y is equal to negative x squared plus 6x plus 7. And our ultimate goal is to try to find the area of the triangle A, B, and C. And let's think about at first how to find the area of the triangle. At first we need the baseline, and if we multiply with the height of the triangle, and we can't forget about multiplying 1 over 2 or divide by 2, this will going to give us the area of the triangle. But at first let's think about the points A and B. The point A and then B will going to be the x-intercept. Let's think about the definition of the x-intercept. So if we convert this into a coordinate, it will going to be x, comma, 0, which means when the x value exists, the y value should be equal to 0. This is what the x-intercept means. And for the x, a, and a b, at first we need a baseline. In general, we can set the a and a b as our given informations, and we can set a and a b as a baseline. And obviously the height will going to be the c to an x-intercept. So this will going to be the height. So instead of b, we can replace it as a, b, segment AB, multiply by the height, which we can just call it as c, and then times 1 over 2, we're going to give us the area of the triangle. And we can use our informations from here. We'll figure out that A and a B are the x-intercepts. But from here, we cannot find the value of it, so we need to convert this into a specific form. And the form that we can use in this case will going to be a binomial form. And then for the binomial form, it is a form that is optimized when it comes to solving for the x-intercepts. So let's think about how to solve for the x-intercepts using this binomial form. So at first, let's convert this into a binomial form, and there will obviously going to be a two nomials, because binomial means there are two nomials. And that will going to give us the y value, which will obviously going to be the output of our function. But we need to remember that even if we convert our form into a binomial form, these forms should be always exactly the same thing with negative x squared plus 6x plus 7, which is our original function, but a different way to express it. At first, there will obviously going to be the x value, which makes x squared, but we need to think about it as a negative x squared. So it will going to be one of the values should be negative x. Think about the unknown quantities that will come out, that I'm showing now, the area. If you multiply with the x terms, and then with this x terms, we're going to get an answer from it. But we need to remember that if you multiply together, it should give us the positive 7. Which means, if we also add it, it should give us 6x. But if you multiply it, will going to give 7, which means all of them should be a positive value. So for the factor of the 7, there is only one factor, which will going to be positive 1 and the positive 7. So we can actually prove it here. Negative x times x, we're going to give us negative x squared, and then 1, and then negative x times 7, we're going to give us negative 7x, and then positive 1 times x, we're going to get positive 1x. But if you add it, we're going to get negative 6x when we get a 6x, which means all you have to do is change the order between both of them. Now we can actually prove it. Negative x, sorry, we need to convert this here. Negative x times 1 we're going to be negative x. And positive 7 times x we're going to be positive 7x. 7 times 1 we're going to be positive 7. And that this term we're going to be 6x, which exactly satisfies our original function. From here, so if you write it down again, negative x plus 7, and then times x plus 1. We're trying to find the value of the output when it is equal to 0. Because x-intercept means when the x value exists, our output of our function, which is 0, which is y, should be always equal to 0. So there will going to be two cases. The first case will going to be when the negative x plus 7 is equal to 0. And the second case will going to be x plus 1 is equal to 0. So there will be two number possibilities of the x values. So for the first one, when the negative x plus 7 is equal to 0, we can subtract 7 to the both sides in order to isolate the x terms, and then we're going to get negative 7 and then positive 7 are going to cancel out. Negative x is equal to negative 7, which means we can divide negative to the all side. We're going to get x is equal to positive 7. But we can clearly see that it is a positive value, which means the b will going to be the 7. The reason is because b is on the positive side of the x-axis, and the y value and the a value is in the negative side of the x-axis. And for the second case where the x plus 1 is equal to 0, we can subtract 1 to the both sides, and then we're going to get x is equal to negative 1. And it will obviously going to be the value of the a value, since we need that a value is located in the negative side. So the a value will going to be negative 1. And if it raises for the more spaces, so we can clearly see that for the distance of this function, we need to always memorize that distance of the function should always be the difference between two coordinates, which means when the a value is equal to negative 1 comma 0, and another one is 7 comma 0. But the difference between y value, there is no difference in the y value, which means for the x value negative 1 and then 7, there is a difference which will going to be a positive 6. Positive 6 is not a right answer because for the distance we only count a positive value, which means we're going to add as 1, we need to consider it as positive 1 and then 7, which we're going to turn as 8. So for the AB, we can replace as, so AB will going to be a positive 8. And we need to find for the C. But C, we can realize that it is a vertex of the function. But since we knew that the vertex is going downward, then only the maximum point should exist. So the C value is a vertex, but we can always call it as a maximum value of our function. So in order to find the value of the C, we need to convert this into a specific form. And we call it into a vertex form, which is optimized when it comes to solving for the vertex of the function. But we need to remember a vertex form is exactly the same thing with solving for or changing the original function into a perfect square form. So if we convert this into a vertex form, at first let's write our function down again, which will going to be negative x squared plus 6x plus 7. And then As a step of converting this into a vertex form, we are only caring about the x terms. But at first, we need to get rid of the negative of the x squared term, which will going to be our leading coefficient. Because if it is not equal to 1, it is hard to solve for it. So it will going to be negative, and we have x squared. Positive 6x divided by negative will turn into negative 6x. Positive 7 divided by negative will turn into negative 7. But we can think about it that if we just multiply or distribute our negative to the every single terms here, we're going to get our original function. Now, at first, we can write this down again as negative x squared minus 6x. And as a step of the perfect square term, the constant will going to be the half of the x term and then square, which will going to be the positive 9. But we are actually trying to find the value of the constant 7. But if we distribute the negative to our 9, it will going to give us negative 9. And the distance between negative 9 and the 7 will going to be positive 16. And this is our vertex form. But we're not done yet. We can convert x squared minus 6x plus 9 as our perfect square. It will going to be negative and then x minus 3 squared, and we still have our constant, positive 16. So our total value of the vertex, which is also a maximum point of the graph, will going to be 3, 16. And this is also a step for solving for the value of the c. But for the c, we're not counting it for the c. We can see that is a maximum value, which is also a vertex of the function. But as a property of the vertex, the y value, which is our output of a function, represents the vertex. Which means when you say that what is a vertex of this function, we also call it 3, 16. We also call it as 16. This is one of our property of our vertex, that our y value, our vertex, should always be represented by the y value. So we can clearly see that c is a value of 16. So if you apply our triangle area format, which will going to be base times height times 1 over 2, we can get base is equal to 8 times height will going to be 16, and then we still have times 1 over 2 or divide by 2, which will turn into 64. So our answer for this question will going to be 64.